Hi everyone. Do you use in-app purchases in your app? Okay, so you are, if yes, if no, you are probably lucky because it can be sometimes little pain. My name is Timar. I'm currently working for Industrial Binaries, and this presentation will be about in-app purchases. This presentation will be separated to four parts. What important parts of implementation in-app purchases. First is how to get available products. So first, before you start write some code, you should log into your iTunes Connect when you should register your app, and then in features you select in-app purchases and register your new StoreKit product. You can write here product name, description, select type of your in-app purchases, and select some product identifier, and select some date when you, for example, select some subscriptions. Then you can move to code and create your own product request with array of product identifiers from previous slides. When you don't have your purchases registered on your iTunes Connect with the same app, with the same bundle identifier, you will never get your StoreKit products. When you fire your StoreKit product request, you should first set your delegate. In current case, it's on the same in-app services. It's StoreKit product request delegate. They have only just one required method. It's a did receive response, StoreKit product response. This product response contains all of your products which you ask to your iTunes Connect, and it's registered on your iTunes Connect. Second part is how you can buy a new product. Do you have iOS device and Apple developer account? I hope yes, but if no, you are probably done. Because for the next step, to buy new product, you need real device. It never works in a simulator, and you need to create new sandbox account in your developer account. For the buy new product, you create new payment queue or you can use default, where you add your transaction observer, and when you then want to buy a new product, you create new StoreKit payment with your selected product and call add for this payment. As you can see, it's a little bit tricky because first time you add payment transaction observer, and second time you add a StoreKit product, StoreKit payment, but it has the same name. Your implementation of StoreKit payment transaction observer can look something like this. They have one required method, it's update transactions. You iterate transactions because this method will call to when you restore your purchases. So you can get more as one transaction. When it's purchases or restored, you just add your payment product identifier, which should be same as your product identifier to your set of your bought products. When it's failed, you should call finish transactions. Third part is very funny. It's how you verify your receipt. So first question is, does your app use consumable in-app purchases? If yes, you are again lucky, because there is only one in-app purchases which don't require validate receipt. It's usually something like buy new life or buy new energy in game. It's immediately add to your user donate. There are three more types. It's non-consumable, auto-enabled subscription, and non-renewing. All of these three types require check your receipt because it should be enabled to your user when you uninstall app on your user login in your different device. For example, Netflix, you should enable user on every device where he log with the same account. Does your app use a server? If yes, you are very, very lucky because there are only just two types of validations. First is on the device, and the second is server-side validations. Server-side validation is just call one post request verify receipt. This is a simple request where you get a JSON response. You can parse it with Codable. It's parser receiver which contain a lot of values which you can read and use it. But when you don't use your app done using a server, is there one big warning? Apple recommend don't use server-side validation because there can be many in the middle and you shouldn't call this post request. And when you verify your receipt locally, you should go to these 5 steps. It's locate the receipt exists, verify the receipt is properly signed by Apple, verify bundle identifier, verify version identifier, and compute the hash of the guide. First is the easy step, is just check if your receipt exists on your bundle main App Store receipt URL. If don't exist, your validation just failed. But you should still think when you're working, for example, with subscriptions, it can mean your user log in the app and you never check this product, but they have it bought. So in this case, you should enable your user refresh receipt or restore purchases. You can do it with the store key receipt or refresh request, where you set a delegate to product request delegate, which will is same like in the previously steps for to get new store kit products. Then when you get a request did finish and your request is receipt refresh request, you can go back to the receipt validation because your receipt should be downloaded in your local device. And this is how your receipt should look like. Is PKCS7 format is in SN1 data, and it's set composed from the attributes where it can be type is number. It defines which attributes you read, version, what is to integer, and the value, what can be anything from the string, date, what is to a string in the specific format. It can be number, and it can be to next set of attributes. On the Apple documentation, there are a lot of the numbers of the types and definition what is it. For example, number 2 is bundle ID, 3 is bundle version, and from the number 17, it's a little bit tricky because on the Apple documentation is purchases, but in real life, in PKCS7, is defined as a set. Then it starts from the 17, for start or you read purchases, for example, quantity, date, expiration date. This is one of the way how you can read your receipt. Apple recommend use OpenSSL and SN1C. This is really nice when you have macOS app, but when you're working on the iOS app, you should download source code for OpenSSL, compile this library, and add to your project. You never should use compiled library because it can contain some exploit, for example. So when you have OpenSSL in your project, you can create new beer with OpenSSL and write your raw data or NS data and transform to unsafe mutable pointer of PKCS7. Then you can go to the next step to read receipt. First, what is important on this slide is get end of your payload and start pointer of your receipt. Then you can read attribute by attribute. As you can see, the first number 17 mean you start read set of the values, but currently it's a receipt, not your purchases. Next time when you read number 17, it means you start read your purchases. Next step of your verification is check your Apple certificate. If your receipt correctly signed with the Apple certificate. First, you should go to the Apple official site where you can download Apple Inc. root certificate. This certificate you should add to your app, to your bundle, and then you can load for the verification of your app. You can load it similar like you load your receipt, you create new beer and write this data to unsafe mutable pointer. Then with OpenSSL, you can simply verify with OpenSSL packet system verify function. Next step is to verify bundle identifier. Your product identifier is unique just only for your app. More apps with a different bundle ID can have the same product identifier. So, for example, when your device is jailbreaked, your receipt can be replaced with the other receipt with the same product identifier. So, this should verify your receipt is from your app. Yes, from your app. Next step is verify version identifier. I'm not sure why you should do this verification. You just check version, but I hope it works. It's based on the Apple documentation. The next step is verify hash. For the verify hash, as you can see, you can use other way. For example, import CryptoKit from iOS 13. You create your own hash with your device ID data, what is vendor string. Then you can update with your opaque and bundle ID. Currently, we use bundle ID raw data from our receipt because in previous step we check bundle identifier is the same as the bundle identifier in our app. Then we just compare our digits with a hash from receipt. And this is full verification. The last part is how you can test it. Do you like tests? Okay, you are probably never lucky with in-app purchases. First is because you should probably cover your app with tests because there's Mindtrain is much simple, but probably you don't know it. You know it. But how you can test it in-app purchases? As I say, you need real device and sandbox account. You can continue with manual tests, but probably you prefer automatic tests on your continuous integration, so you can separate your part of your codes to just small functions and test this. And you can create, for example, this extension of StoreKit product, where you can create new with specific product identifier, price, and price locate. This is only one way where you can test your in-app purchases, but you cannot test a lot of things which you can test only on the real device. All this code you can see in the Yoda project is is working with OpenSSL. Usually it's under MIT license. You can create new pull requests for this, and it's distributed with Swift package manager, so you can simply add to your project. Any questions?